Hello everybody. Today I'm very excited. Why am I excited? Well, I've got the latest offering from our buddy Alarm Hookup on eBay, and wait till you see this thing. There you go. This is the Headway 38120 HP 3.2 volt 8 amp hour LifePO4 lithium battery. Okay, this is a pretty marvelous little cell. Now it's capable of doing 200 amp draw. It's nuts. Okay, so he's selling these on eBay. I'll put a link to it in the video description below just to give you an idea. This is an 18650 cell beside it. This is the NCR 18650B from Panasonic, and you can see the difference. Okay, it's a monster cell. It's amazing. Okay. Again, I'll get into the physical attributes and size and weight and so on a little later on in this video. But I just wanted to show you this monster. And he's selling 4 of these for $33.99 plus shipping. Okay, so I'll break down the prices for you and everything about these cells here in a second. But just wanted to show you this thing. It's just amazing. And it comes with screw-in terminals on both the negative and positive end, the anode and cathode, and which allows you to basically screw in and attach cables, connectors, or even plates if you want to make your own battery any way you want. Now, this is LifePO4, so that makes it a lot more stable a battery than a lithium battery. It makes it a more constant voltage battery too, and you'll see that on the charge curves when I show you the actual the discharge curve when I show you the actual test to see what the capacity is. But I'll comment on that here in a second. Let's move over to the actual specifications from Alarm Hookup on eBay. Again, in the video description below, there's a link for it. Again, Headway 38120 HP, 8 amp LifePO4 chemistry. And these are unprotected cells, so understand there's no protection circuitry in these. You're dealing with a live raw cell. Again, 8 amp hours or 8,000 milliamp hours in total. Amazing. Alarm Hookup or Tom on eBay is claiming 95% capacity, which would make them 7.6 amp hours or 7,600 milliamp hour capacity. My preliminary test on the first cell actually shows that he's more or less, I think, just covering his butt, because the first one I tested was 8112, and I didn't fully discharge it all the way down to 2 volts. So preliminary tests looking really good. I'd say more than 100% of capacity on the first cell. I've got 3 more to test. I'm testing the second one currently, and understand these are 8,000 milliamp hour cells, so they take a while to test each one. But so far so good. Let's break down what the actual cost would be for 4 of these cells and what you get with the 95% capacity that he's claiming. I'm actually thinking you're going to do better, but that's what he's claiming. So we'll go with that. So 4 cells, $33.99 plus $13 shipping. He does give you discounts on bulk orders and shipping, so it would get cheaper. I'm sure you could put 8 cells in the same size box that he sent me 4 in, so I'm sure the shipping would be that much more. So he's claiming that on the actual eBay listing as well. So total cost for 4 of these raw cells is $46.99. So that means $11.75 each for a 7.6 amp hour cell. I'm saying 7.6 amp because he's saying they're 95% capacity, though I'm finding that they're much more than that. And like I said, I'll show you what those results are when I'm done. And so basically that turns into $1.75 per 1 amp hour, or $1.55 per 1 amp hour, or $1.55 per 1,000 milliamp hours. So pretty good deal. Amazing 200 amp max capability. I don't know what you need 200 amps for on a cell, but I hear that the car enthusiasts, audio enthusiasts use that much power to run amplifiers, which is insane. But anyway, that's another thing. Whatever you need it for, that's what it's capable of producing. Now, LifePO4 chemistry is more stable. It's safer than lithium-ion cells. Do your research on this type of battery before purchasing it so you know what you're getting. But they are generally chemically safer. They're less likely to have a catastrophic failure if they're damaged. Okay, so read up on that. You'll find out what the limitations are. But yeah, they're claiming they're better for EV vehicles as well. So if you're going to use this in an EV vehicle, great thing to have. 8,000 milliamp hours on one, just amazing. But again, the LifePO4 battery management systems, or BMSs, are different than lithium-ion ones. So you need to buy the right, circuitry and BMS for these cells and their chemistry. So be aware of that as well. So do your research on that as well. Okay. When these are fully charged, they come up to 3.65 volts. That's the maximum charge that you should put into them. And if you multiply that by 4, that's 14.6 volts, which basically, if you know about automotive lead-acid batteries, that's generally where those cells are topped up at, around 4.1, 4.2, maybe a little higher volts. So if you have lead-acid batteries at 12 volts, four of these put together in series are actually a very good replacement for those, and they're much, much lighter. So you're going to get, all the voltage you need, plenty of power, and a lighter application. Now, understand that you can't replace these batteries directly with lead-acid batteries, or lead-acid batteries directly with these cells, because these are LifePO4. So yes, you can use them 4 in series as a 12-volt battery, but you need to understand that they need to be charged in a certain way. They cannot be charged willy-nilly by just putting 14 volts of voltage on them. It just doesn't work. You need a constant charge, constant voltage charger to charge them up. Otherwise, you'll destroy them. So that's the same with lithium batteries as well. So understand that about this chemistry. So again, do your research, find out what you need to actually make it happen. Again, these are from my preliminary test on the first cell. I got 8,112 milliamp hours, or 8.112 amp hours of discharge from that cell, and I did not discharge it all the way down. So I'm actually getting more than the claimed 8 amp hours on these cells, which is simply amazing. But what I will do after I'm done everything else, all the other testing I'm going to do with these cells, I'm going to build a 12-volt battery from 4 of these cells, and I am going to connect it to my car, and I'm going to start it. I'm really keen to do that project, and I'll show you how I built the cell and how I connected it to my terminals. It's going to be very basic. It's not a permanent solution. It's just something I'm putting together to test these cells and to show you that it's possible. So can't wait to do that. So next, we're going to go into the physical attributes of these cells. I'll measure them, I'll weigh them, and show you what they look like from top to bottom. Let's look at the physical attributes of these monster cells. First off, I noticed, and alarm hookup does say, from eBay, does say that they are not brand new cells. They are used cells. I don't know where they were harvested from, but they were harvested from something. And I will put a link to these cells in the video description below for you guys, so you can get them from alarm hookup on eBay. But physically, they may be a little scuffed up, a little marred up. As you can see here, some of these, the insulations may be a little cut on the outside here, like this one, right? A little crack here. I don't know if you can see it or not. Yeah, there's a little crack there. And, there might be a dent or ding, like here, there's a dent, but that doesn't really affect anything. Oh, look, here's some insulation here that's been worn off. So, I'll get into the electrical properties of this cell in a minute as far as what is physical, because they're different than a lithium, that's for sure. So, again, just look them over. You can see some are better than others, right? This one here I don't think has any breaks in the insulation, but it does have a ding or a dent in it right there. And on this one here, similar kind of, minor damage here, a little bit of a crack on the insulation on the top. But again, they're used, and you're being told that they're used, so expect some wear. It's not a big deal. Now, alarm hookup. On their description for these cells, they say that they're guaranteed 95% capacity, which I believe is 70 or 7.6 amp hours. So you should get a minimum of 7.6 amp hours out of these cells, or 7,600 milliamp hours. Now, I've tested a couple of these, and both of them have rated higher than 8 amp hours. One was 8112, so 8,112 milliamp hours, or 8.112 amp hours. The other one was 8959, so 8,959 milliamp hours, or 8.9 milliamp hours. So that's well above the 8 amp, rated capacity. So I'm testing the third one here right now. Hopefully it will come up higher than 7.6 amp hours. All of them so far have, but they do take about 5 hours a piece to test. So I'm working my way through them, and I will give you all those results when we're done. So let's measure them out and weigh them out so we know what we got, and so you guys know what you're getting and what size you're getting. All of them come with these little screws at the anode and cathode end, just to really nice feature, so you can actually just screw a connector onto it, a wire, or in my case, I'm going to make a 12-volt battery out of them, and I'm going to be using a flat steel bar like this, which I know is rated higher than 200 amps, because a similar bar made out of copper would handle more than 200 amps. So this bar will do it no problem. And all I'm going to do is just hook them together using those very convenient screws, and connect them in series to make a 12-volt battery. Now, the maximum voltage on these cells is 3.65 volts. So 4 of them put together will go over 14 volts. So, hey, really nice. And really a good application for 12-volt systems. And I'm going to take that cell, that battery I make out of these cells, and actually start my car with it. I don't have a 200 amp capable meter, so and it should be able to start my vehicle. At least I think it should. So we'll see. I'll build a cell, and I'll definitely show you that test while it's being done, and video that for you. So let's take these screws out. They just unscrew counterclockwise, and you get a screw for each end for each battery. So that's a really nice thing to have. Here we go, and you can see the top looks like it's vented all the way around, so that's probably a safety feature. And the bottom has just the cathode there, and some a black insulative area around it, and then of course the jacket. So I'm going to get into the peculiarities of the cell in a minute, but right now let's just deal with the size. So size wise, in millimeters, it is 133.81 millimeters, or in inches, 5.269 inches, or 5 and 35 1/28. That's the length. Diameter is in inches. You can see it, half an inch, or 38.06 millimeters, or 1.50, as you can see, if I get it right, 1.50 or 1.5075, which is basically an inch and a half. So that's the diameter and length. Next, we're going to take the weight, and I seem to have lost my scale. Oh, here we go. Got my scale here. We'll hit the button here. Got it 0. We're in grams off the bat. Hopefully I can get it and not roll off. There we go. 335.4 grams. And if we go to ounces, it is 11.830 ounces. So, there's the weight and size of these things. Now, I said I was going to get into the electrical peculiarities of this cell in comparison to a 18650 cell. Okay, so this is a Panasonic NCR 18650B. A really nice cell, but it's an 18650, and all the 18650s I've seen have this same thing. The positive anode on the top, of course, and the negative cathode on the back. But the whole outside shell casing of the actual cell is negatively, it's hooked up, it's part of the negative. So it's all insulated and protected so that there's less chance of short to the positive with the outside of the jacket, because anywhere on the jacket would be positive. Would be negative. So yeah, if you have one of these and the insulation's gone on them, I would say watch my videos where I show you how to shrink wrap them, because it's a safety issue, okay? Well, that's the 18650 cell. Now, this cell, when I took my meter to it, I was quite surprised of what I found, and I'll show you what I found. This one's quite easy because it has a little wear mark here on the outside part of the cell right there. So I can actually get to the outside jacket, the metal jacket around the battery. So if we go and we'll see how much voltage there's in it. There's 2.69 volts. So this cell has been discharged by me. So it's 2.69 volts in it right now. Okay, and if we go from the from the positive to the jacket, you'll see a small, almost half a volt difference. So there's about half a volt going to that jacket. From the positive anode to the outside jacket, which is kind of strange, but there it is. So you don't want to short the outside jacket to the positive lead, that's for sure. And also, if I take this, now you see that I have 2.26 volts from the jacket to the negative lead. So there's a possibility of shorting from the negative, obviously much larger difference in voltage from the negative cathode to the jacket, but 2.254 volts right now, and you can see it's going down probably because of what I'm doing right here. But that's not the voltage of the battery. So if we go here, it's 2.695, right? So yeah, there's a little bit of a difference there. So it's not a positive jacket, it's not a negative jacket. I would say it's mostly positive, but it's losing something somewhere, okay? In this case here, as you can see. If we go from the jacket to the positive cathode, there's almost a 0.5 volt difference. So careful with the jacket. Don't short it either to the positive or the negative, as you will discharge the battery, and probably quite quickly, right? So something to consider on these things. Careful with the jackets. Don't short them to either positive or negative. And you can see on the back this strip here of insulation between the negative cathode and the rest of the battery. That's probably a safety feature, as well as it's standing out further from the actual casing itself, so that when you do connect, it won't easily short to the jacket. Same with the top. The top also stands out, and that's the same reason. They don't want you shorting to the jacket. So careful with that. Be aware of it, but it's not a big issue. It's certainly different than it is than one of these 18650s. And look at the size difference. Oh my goodness. It's like no comparison. All right, so next I'm going to assemble this battery using these little bus bars that I have. I made them out of a flat piece of steel. I know you guys are going to ask me, whoa, what size are those? Okay, so I have, let's start with millimeters. Okay, so like 59 millimeters. I didn't go perfect on this. I went from 62 to 59 millimeters, and it was just because I was cutting it with an angle grinder, and I didn't do that great a job. But that's the length, and in millimeters is 4.89 in thickness, and 15.90 millimeters in width. Now I know a copper bar of this size will carry more than 200 amps, so I'm thinking the steel bar will do it even better because it's made out of steel. It's harder, stronger, denser metal. So in inches, it is 5/8 by 3/16. You guys can see that, by sorry, and the length in inches is 2.2 and 11/32, or again 2.38347 inches. So, you know, no big deal there. You guys can figure that out. The holes are just slightly bigger than the screws. And what size are they? Let's see if I can get a measurement. 29 1/28 in inches, or 6 millimeters, 6.09 millimeters, or 0.2400 inches. So, you know, you figure it out. But basically, I got this piece of bar steel from an old Harbor Freight clamp, so I just harvested it. The clamp no longer worked, but the bar certainly will, and it's nice steel. I just ground down the ends so I have good clean surface area to contact with the cells, and then I'm just going to attach them to the ends and make a battery, a 12-volt battery, by connecting all these cells in series. So next, we'll move on to the capacities of all these cells, and after that, I will connect this battery that I make to my car, and we're going to start the car up. On the screen here, you see my output from these 4 cells. I've tested them down to 2.15 volts, which is not the lowest range they could go. They could go down to 2 volts, so I didn't want to fully discharge them. They were pretty close to fully discharged, but you can see from the results that all of them surpassed the 7,600 milliamp hours promised by alarm hookup. And one of them went way up to 9,048 milliamp hours, which is huge. It's 1,000 milliamp hours higher than the specification from the manufacturer. So yeah, these cells can go way up, and obviously all of them surpassed what was promised, and 3 of them were above the 8 amp hour or 8,000 amp hour mark. So excellent value. So happy with that. I want to show you something else with these cells too. I'll flick over to the next image, and you can see how stable these things are on voltage. They're just pretty well, you know, they hit 3.2 and they just stay pretty well in that range for most of the discharge cycle. Again, towards the end, of course, they drop off. This little blip here, that was just me. I knocked into the charger, so it caused that to happen. So, you know, basically I moved the connections on the battery as it was discharging. You see the second one, it's, error-free here. And again, pretty well a flat line all the way across. And then towards the end, of course, it drops off heavily. But that's normal for any cell. So as you can see, LifePO is a very stable and solid performer across a narrow voltage band while it's discharging. So another plus about these cells. So at this point, what I'm going to do, put this battery together, show you the thing, assemble the 12-volt battery to start my car with, and show you that. And then we'll go from that out to the car, disconnect my battery, and try these cells out on the car itself. Here we have the monster battery that I built with these beautiful cells. You can see that it starts on, this is the positive side here. You can tell by the notch on the top. Positive goes to, basically go from here to the negative to the positive on the next cell, and over, and it continues on a loop all the way over here, this being the negative terminal. So positive, negative, and you could fold it up and make it a square battery. I've got it as a straight battery like this, just to show you what it looks like. I may fold it and turn these 90 degrees and have it like a square battery, as if it does start my car. I mean, I think I'll just keep it around as a spare boost battery, something I keep in the trunk, and say, hey, if I ever need a boost, I can always hook this thing up to the car and boost it up and start it. Well, we'll see how it performs once we connect it. But here you go. I've got all the bolts on top. I stripped one of these, so I used another carriage bolt in there and fit perfectly. Bottom half, same thing again, as you can see, in series, ready to go. So let's test the voltage out on this and see what we get. Let's bring the meter over here. There we go. And again, you can tell which is the positive by the notch on the top, right? So the notch on the top is the positive, Let's just take a look and see what we got here. 14.36. And understand we're dealing with a 200 amp battery at this point. So be careful with this thing. Don't short it to anything because you'll be arc welding basically. Yeah, ready to go. So next thing, we put it in the car. I will take the lead acid battery out of my car and just boost it bare without any battery in the car to see if it'll start it with that. And I'll probably use jumper cables to connect to it. I don't really want to connect it permanently to my car. I've got my battery connected right now to the negative terminal and the positive terminal on the vehicle. I've got the engine running. I started it with the original battery, the car battery. So I'm just letting it charge a little bit and warm up a little bit. And so currently the car is running on this battery alone, not the actual lead acid battery. Okay, so you know, you see the terminals here and over here. So I basically bolted directly to them. So I'm going to shut down the car and then try and start it. Well, there you go. We just started up the car. You know, I'll prove that here. I'll take this cardboard away and you can see the battery underneath it. If I can get that off, there we go. And you can see that there's nothing on those terminals. Hopefully you can see that. Positive terminal, negative terminal underneath the battery. So I put the cardboard there to insulate it. I don't want it shorting out to anything. So put it back and we'll try that one more time. Pretty cool. Well, I had my doubts, but the test proves that it does work. So you can actually start a car. This is a V6 3500 cubic inch engine. So as you can see there on the label. And let me see if I can get you a better angle on this. There we go. And you can see how I got that hooked up. Right there. Okay. So yeah, positive terminal, negative terminal, screwed right in, working like a charm. Amazing. All right, to summarize, I'm very impressed with these cells. They're just amazing. I can't believe that 4 of these will start my car. I mean, it's a 6-cylinder, 3.5 liter engine. Incredible. Just amazing. So yeah, you know, these could be used as a lead acid replacement. I would probably use 8 instead of 4 in my vehicle, and I would also put a proper charging system with a BMS on it before I used them. I mean, I used them bare today, but I mean, it was a limited use, so it's not going to hurt them for that little bit. But just amazing. These Headway 38120 HP 8 amp cells, LifePO4 chemistry cells are amazing. I just can't believe how well they work, how powerful they are, and how small the package is, and and light too. Very impressive. So yeah, that's I have no problem recommending these if you need that much power and that much amperage. Obviously we got 200 amps out of them, rated out of them. So just incredible. Again, I'll put a link in the video description for these from Alarm Hookup on eBay if you want to buy them. They're, he's got them in stock, but they're a limited quantity, so he will run out of them. And these cells, brand new, are way, way more expensive than what he's selling them for, so it's a pretty good deal. Okay, that's it for my video. If you like this video and it helped you out in some way, do me a huge favor and click on the like button here on the bottom right-hand corner and give me a thumbs up. It helps my videos and I greatly appreciate that. Also over here on the screen, you'll see a picture of me. That's a subscription link. All you have to do is click on that and you'll be subscribed to my channel. Also, in the process of subscribing to my channel, YouTube has added an extra feature, and that is the bell icon. If you click on the bell icon, you'll be notified every time that I put a new video up, and then you can watch it at your own leisure. Once again, and like always, I want to thank you all for watching and for your time.